In 7.3, we will still continue solving linear systems, but this time it will be by linear combinations. Linear combinations is obtained by adding one of the equations to get the result of one variable. Then we go back and do the same thing as we did in 7.2, substitution to solve for the other variable. You can come back to the screen if you need to. We'll go ahead and put it in action. So we have a linear system here, 4x plus 3y equals 16, 2x minus 3y equals 8. The goal is to have only one variable to solve for. So as you can see in these two equations, we have a positive 3y and a negative 3y. Therefore, we can eliminate our y variable. So when I combine those two equations by addition, I would get 6x, my y's would cancel each other out, and then 16 plus 8 would give me 24. Then I would divide both sides by 6, and I would get my x equals 4. Now that I've solved for one variable, I can do the same procedure I did on 7.2, and I can substitute that into either equation. I'm going to use the one with all positives. So 4 times 4 plus 3y equals 16. So that would be 16 plus 1 equals 16. So I know that my y would equal 0. So my solution written in coordinate in a coordinate point would be 4, 0. Now again, checking this, we can check this either by putting it on the Desmos calculator, on the scientific calculator, and seeing if this is the intersecting point, or by mentally putting it into the other equation. So 2 times 4 is 8, minus 3 times 0, which is 0. Does that equal 8? And yes, it does. Remember, the xy should satisfy both equations to make it a system. Let me go back here. It looks like I had one other. Let's see if there was a note here I wanted to pull up. Nope, I don't know why we have another blue line down there. Okay, going to the next example then. So to example 2. This time when and again, you want to line up your equations in column form. So you want your x's to be together, your y's to be together, and your constant terms to be together. This time, I cannot eliminate just by combining the two equations. But I can eliminate my x's if I multiply them, because I have a positive x and a negative x. So I'm going to go ahead and I'm going to multiply the first equation by 4, a positive 4. So the whole equation multiplied by a positive 4. And then the second equation I'm going to multiply by a positive 3. So in my top equation, 3x times 4 would give me my 12x. 5y times 4 gives me 20y, and 6 times 4 gives me 24. In my second equation, negative 4x times 3 gives me a negative 12x. 2y times 3 gives me a positive 6y, and 5 times 3 gives me a positive 15. Now you can see in column form there that if I combine my x's, I have positive 12x and negative 12x. They're going to cancel out. It looks like I skipped a little step here. I would get 20y plus 6y would give me 26y. I think just because I was having some trouble with it writing, I went ahead and typed some. So let me see if I can write it in there clear enough for you. So my next step would have been 26y. If we can tell that's a 6. 26y equals 39. And you'll see in this case, and this is following along in the book, they went ahead and they put it in decimal form. Since we're not dealing with slopes and intercepts, slopes that need to be in fraction form, you usually change fractions into mixed numbers, or so that you can you usually change improper fractions into mixed numbers so that you can graph them correctly. It's also easy to graph a decimal. So I'm fine if you want to go ahead and you divide both sides by 26 and you get 1.5. If you really love doing mixed numbers, then you could go ahead and reduce that and you would get 1 1/2. Now I'm going to do the same thing that we were doing in the last lesson. We're going to go ahead and we're going to substitute our answer in for the variable we solved for and then solve for the other variable. So we have we solved for y first, use that for substitution. Go ahead and do the math where you're substituting in the y and solve for x. And then the final step, make sure you're writing it in the coordinate point form. Negative 0.5 or negative 1/2, and then 1.5 or 1 1/2. Again, checking this by substituting it into the other equation, making sure it solves, it is a true statement for the other equation, or by plugging it into Desmos and seeing if this is the intersecting point. So this time we start out with the equations, and they're both in different forms. We have the first one in standard form, and we have the second equation looking like it could be going into slope-intercept form because we have y isolated. So the first thing I'm going to do is put them both into standard form. So you see I have the first one the same, and then I've just moved terms around. Again, you can take the shortcut of crossing the river. Just be careful with that. So the only term I moved in equation 2 was I moved the negative 5x. So when it crossed the river, it changed in, or went to the other side of the equal sign. It changed to a positive 5x. I kept my constant term 12 on the same side, on the right side of the equal sign, so it still stays a positive 12. Now I'm going to have to do the same thing as I did on the last one. I'm going to have to find, I have all positives. So when I combine them, I'm not going to get anything to cancel out. However, in this one, I'll go back to the black so you can see it a little bit better. In this system, I have the same term, positive 2y. So all I need to do is really get one of those as a negative. So if I go ahead and I multiply the bottom equation by a negative 1, changing everything to its opposite sign, then my y's are going to cancel out. Again, we have one line missing here. So I would get a negative 2x when I combine 3x with negative 5x. And then I would get that equals a negative 4x. I'm sorry, a negative 4. Divide both sides to solve for your single x. And negative 4 divided by negative 2 gives me my x equals 2. So then I go on to the same step you've been practicing in the lesson before this. And I'm going to take that answer, substitute it in. So now in the next equation, I only have one variable. 6 plus 2y equals 8. I'd subtract 6 from both sides, so 2y equals 2, and divide both sides by 2 to solve for my single y, and I would get y equals 1. So again, writing my final expression as a coordinate point. So now we're going to model a real life situation. And so the background there on gold and silver, I'm going to jump down to example 4 to keep this short. A gold crown suspected of containing some silver was found to have a weight of 714 grams and a volume of 46 cubic centimeters. The density of the gold is about 19 grams per centimeter. The density of the silver is about 10.5 grams per centimeter. What percent of the crown is silver? So we need to go ahead and set up, I think I have this on the next, I do. So I've copied that again so we can refer to it. We have two different equations. We have an equation about volume, and we have some information or equation we can make about weight. We know the total volume of the two metals equals 46. So I can say gold plus silver. So I went ahead and just used those as my variables. G plus S equals 46. I guess I could give it an equal in there. My other equation is talking about volume, and we find volume by multiplying the density times the volume. I'm sorry, it's about weight, and we find weight by multiplying the density with the volume. So I know that the density of the gold was 19 grams, but I don't know how much volume we have. So that's going to be 19G, and then my silver density is the 10.5, and that's multiplied by the volume, which I don't know still from the first equation. So that's going to be 10.5S. That's going to be equal to, having some problems with my equal to signs, I guess, equal to 714 grams. I'm going to set those up again in the columns. So I went ahead, and this time, because I had nothing that would cancel each other out, I multiplied the first statement. Let me go back to that a minute. The first statement by 19. I needed to multiply to make sure that one of my variables would, when I combined them, would cancel each other out. I could have also, I multiplied the top equation following the book by a negative 19. So everything in the first equation is multiplied by negative 19. If it was me, I probably would have multiplied everything by the 10.5 instead, just because it's a smaller one and you deal with smaller numbers. But it does not matter. So following the book, we end up with negative 19G. We end up with a negative 19S. And then we had to go ahead and multiply to get that new total, which is negative 874. When I combine them, the G's cancel out. And I get that negative 8.5 of the silver equals negative 160. I'm going to divide both sides by negative 8.5, and I'll end up on my calculator with an 18.82352 ... It just keeps going. It is not a terminating decimal. So the volume of the silver is about 19 centimeters. If you remember, we're just kind of, we're going to have to use some estimating here. So if I go ahead and I put that back into my original sentence, which was G plus S equals 46, and now I know my S is going to be 19. The crown has a volume of 46 centimeters, so I'm going to get 19 divided by 46 is about 41% is the silver. Okay, I did not need to go ahead and find out the gold. The only part they ask me in the question is the silver. So if the entire crown is 46, and I know the silver, I can go ahead, kind of like Power School. The quiz was worth 46 points. You received whatever the amount of silver was, which happened to be 19. Then we could go ahead and divide that and get it at about 41%. Okay, that concludes lesson 7.3. And that again is linear combinations when you combine to eliminate one of the variables.